So we have seen a relation between apparent depth and real depth. When object is in denser medium viewed from rarer medium, or when object is in rarer medium and viewed from denser medium. Now let us see shift in position of image. Suppose this is the denser medium and here there is an object, ray goes normally, undeviated, incident at this point, angle of incidence I, so this angle will also be equal to I, ray goes like this, so this is position of image and this is position of object. This is apparent depth and this is a real depth. Here it is viewed from here and object is in denser medium. So we have seen relation between apparent depth and real depth. Apparent depth upon real depth is equal to refractive index of observer medium to that of refractive index of object medium. So here observer is in air, object is in say water. So A divided by R will be 1 upon mu of water. So here apparent height will be real height divided by mu of water. So this is a relation, we already have derived this. Now from O to I, this is called shift in position of image. Object is here, image is here, so this is called shift in position of image. Shift or normal shift, it's also called normal shift. Normal shift. This whole is R and this is A. Let this point be P. So we can write PO is equal to PI plus IO. PI plus IO is equal to PO and PO is equal to real depth. PI is apparent depth and this is called shift in normal shift, you can say delta X. So here delta X is a real depth minus apparent depth. So real depth minus apparent depth, that is real depth upon mu of water. So it is R 1 minus 1 upon mu water. So this is formula for normal shift. When object is in denser medium and viewed from rarer medium, this is formula for normal shift. This is called normal shift. You see object here when seen from air instead of this position. So this is apparent shift or normal shift. Now if object is in rarer medium and viewed from denser medium, then what will be formula for normal shift? Suppose this is rarer medium and this is denser medium and object is here. This is object. So ray which is incident normally goes undeviated. Another ray incident here. This is angle of incidence as it is going in denser medium, so it will bend towards normal. So it will be like this. If you extend this ray, here there will be position of image. So this distance is said to be real height. It will be Pu, this is O, this is I. Sorry, this is apparent height and this is real height of object. Normal shift is this. This is normal shift distance between object and image. This is called normal shift. Here too, apparent upon real, refractive index of observer medium, that is mu d, because it is being observed from here. So it is mu d, refractive index of object medium, mu r. So A will be mu d upon mu r into r. Now apparent shift, PO plus OI is PI. So here PI is equal to PO plus OI. PI is apparent height, PO is real height, and this is normal shift. So normal shift is A minus R. So it is mu d upon mu r into r minus r. So this is r mu denser medium upon mu rarer medium minus 1. So this is formula for normal shift when object is in rarer medium viewed from denser medium. So these two expressions should remember. Suppose this is medium 1, this is medium 2, and then here there is air, refractive index mu 2, refractive index mu 1, and there is an object somewhere here. This is object O. Thickness of this is T1 and thickness of this is T2. So ray will go like this. Suppose first incident somewhere here. This is angle of incidence I, and as it is going in, let mu 2 is lesser than mu 1, then it will go like this. So this is image I1 and this angle is R1, angle of refraction. So this angle will be I, this angle will be R1. Let this point be P1, this point be A1, and this is O. So applying Snell's law at point A1, we can write mu 1 sin I is equal to mu 2 sin R1. Now here angles are small, so mu 1 tan I is equal to mu 2 tan R1. We can write angles are small, so mu 1 now tan I1 perpendicular upon base. It means P1 A1 divided by P1 O. P1 O. O A1 P1 in this right angle triangle, tan of this angle I is perpendicular upon base. Perpendicular upon base. In triangle O A1 P1, tan I1 is perpendicular, that is A1 P1 upon base, that is P1 O, is equal to mu 2 into tan R1. In this right angle triangle, tan R1 is A1 P1 upon P1 I1. P1 A1 upon P1 I1. So from here this is cancelled. So mu 1 P1 O is T1 upon T1 is equal to mu 2 upon P1 I1. So from here we can find P1 I1. This will be T1 upon mu 1 into mu 2, right? Now this angle will be R1, this angle equal because it is transversal. Let this point be A2, this point be P2, and it is just to make you understand P2 and A2 are quite far away. A2 is very close to P2, only then angles will be small. So it is going in air, so light will go like this. This is the position of final image. So this angle is R2, so this whole angle is R2, this angle is R2. Now if I use Snell's law here, it is mu 2 sin R1 is equal to mu air, that is 1 into sin R2. Angles are small, so it is tan R1 is equal to tan R2. Now mu 2 tan R1, take this triangle P2 I1, because this is object for this surface. So P2 I1 A2 in this right angle triangle. Tan R1 will be P2 A2 upon P2 I1. P2 A2 upon P2I. Now see once more. In triangle, right angle triangle, in right angle triangle, P2 A2 I1 tan R1 is P2 A2 upon P2 I1. In right angle triangle, P2 A2I tan R2 is equal to P2 A2 divided by P2I. In this triangle, P2 A2 and I, in this triangle, tan R2 is A2 P2 upon this, and P2 I1 A2 in this triangle. Tan R1 is A2 P2 upon P2 I1. So these values I put here. Now this is cancelled. So mu 2 divided by P2I is equal to tan R1 P2 I1. This is P2 I1. So it is P2 I1. It is 1 upon P2I. 1 upon P2I means this. This is the apparent height, because final image is this. So distance between this point and this is called apparent depth, and distance between this and this is called real depth. So this is apparent depth, 1 upon A. Now P2I1 is P2P1. P2I1 can be written like this: P2P1 plus P1I1. This whole can be written as P2P1 plus P1I1. So P2P1 is T2, thickness of this slab, and P1I1 we have already calculated. So it is P1 into mu2 upon mu1. This is P2I1. Now put value of this P2I1 from here in this equation. So it is mu2 divided by T1 plus, sorry, this is T2, T1 upon mu1 into mu2 is equal to 1 upon A. If I cross multiply these two, then it is T2 plus T1 upon mu1 into mu2 is equal to mu2A. Divide whole equation by mu2. So T2 upon mu2 plus T1 upon mu1, this mu2 will be cancelled, is equal to A. It means apparent height is T1 upon mu1 plus T2 upon mu2. So this is apparent height in this case. It means if there are two slabs, then apparent height is T1 upon mu1 plus T2 upon mu2. If there are three slabs, then apparent height will be T1 upon mu1 plus T2 upon mu2 plus T3 upon mu3. If 4 slab, then T1 upon mu1 plus T2 upon mu2 plus T3 upon mu3 plus T4 upon mu4, and so on. So this is the general formula. Now you can remember. Now shift in this case is, this is apparent and T1 plus T2 is real. So this much is OI is shift, normal shift. So in this case, normal shift, if you want to find, normal shift delta x is real minus apparent. Real depth is T1 plus T2 from here to here. So it is T1 plus T2 minus apparent T1 upon mu1 plus T2 upon mu2. So if I write it like this, T1 minus T1 upon mu1 plus T2 minus T2 upon mu2, then it is T1 1 minus 1 upon mu1 plus T2 1 minus 1 upon mu2. This is total normal shift. This is shift produced in first slab and shift produced by second slab. So if there are 3 slab, then total shift will be T1 1 minus 1 upon mu1 plus T2 1 minus 1 upon mu2 plus T3 1 minus 1 upon mu3, and so on. So that is how you are going to find apparent shift. What is equivalent? Suppose I have a single slab whose thickness is T1 plus T2, whose refractive index is mu, and that is producing same amount of shift as produced by this. Then what should be refractive index of that single slab? So equivalent refractive index. Suppose I take a single slab whose thickness is T1 plus T2. Put an object here and its image is formed somewhere here. So this is shift. This is apparent depth. If refractive index of the single material is mu, then apparent shift in this case will be real upon mu, and apparent position depth in this case is T1 upon mu1 plus T2 upon mu2. Now if these two are equal, then we can write T1 plus T2 upon mu is equal to T1 upon mu1 plus T2 upon mu2. You know, these two together giving this result and that single slab giving this result. If I want to replace these two slab by a single slab and I don't want to get any change in apparent depth, then what should be the mu of this single slab? That is equivalent mu we are going to find. So A should be same in both cases. That's why I equated A in both cases. Now simplify this. This is formula for equivalent refractive index. This mu is equivalent refractive index. Suppose these two slab is of same thickness. If T1 is equal to T2 is equal to T, then this become 2T upon mu equivalent is equal to T common mu1 plus mu2 upon mu1 mu2. So this T cancel. So mu equivalent will be 2 mu1 mu2 divided by mu1 plus mu2. This is equivalent refractive index if both slab have same thickness. If they have different thickness, then you have to use this formula. Suppose an object is in denser medium. Suppose this is denser medium and this is rarer medium, and here object is like this. This is an object whose length is perpendicular to interface separating two surfaces. So this is my object. Now how image of this object will be formed? The ray which is going perpendicular, it will go undeviated. The ray which is moving from this end of object incident here, the ray which is moving from this end get incident somewhere here, as it is going in rarer medium, so it will go away from normal. It will go away from normal. So this is position of image. So this is the kind of image you're going to see. This is height of object. This is height of image, h prime. Then height of image upon height of object is equal to mu rarer upon mu denser. So height of image will be mu rarer upon mu denser into height of object. Means here image will be shorter and it will be lifted. So image of this object will appear here and it will be shorter, and you can find height of image by using this formula. Suppose it is denser medium, it is rarer medium, and object is like this. Means object is parallel to refracting surface. Then this is incident ray. This will be image. So length of object and length of image both are same. So when object is parallel to a refracting surface, length of image is equal to length of object. There is no change. So if you take a cube that has height as well as width, then in image you are not going to see any change of dimension of width, but you are going to see change in dimension of height. Or glass cube. This is 12 centimeter. There is an air bubble inside this glass cube. When it is seen from this side, it appears 3 centimeter from the surface. From this side it appears 3 centimeter. This appears 3 centimeter from the surface, and from this side it appears 5 centimeter from the surface. Then find refractive index of this glass cube. So if I take this as a real depth, then when viewed from site 1, apparent upon real is mu observer, that is 1, mu of this glass, it is not known. So this is 3 divided by r is equal to 1 by mu. So from here r will be 3 mu. This is relation 1. Now when viewed from this side, real depth will be this 12 minus r. This will be real depth, and apparent is 5, that is given. So when viewed from second side, apparent upon real is mu observer 1 upon mu of this glass. So apparent is 5 and this is 12 minus r is equal to 1 upon mu, or 5 upon 12 minus, at place of r we can write 3 mu is equal to 1 upon mu. Cross multiplying, 12 minus 3 mu is equal to 5 mu. So 12 is equal to 8 mu. So mu is equal to 12 by 8. So 3 by 2. This is refractive index of this glass. So it is a glass cube in which there is an air bubble. When seen from this side, it appears 3 cm below the surface, and same bubble when seen from this side, it appears 5 cm from this surface. Then find refractive index of this glass cube. That is my question. It is solved like this. From this surface, what is actual depth of the surface of the air bubble? You can find r. R is 3 mu. So 3 times mu, that is 3 by 2. So 9 by 2, 4.5. So this is 4.5. And then this you can also find 4.5, 12 minus 4.5.